that. Under systems of equations,
What page? What page? 437.
systems of equations there. Take a look at page there. I just want you to write in your notes that little graph where they have there. When you have systems of equations and you're graphing them, they give you two options. In other words, when you have, let me just show you this here. When you have something that looks like this, x plus 3y equals 6, and 1/3 x plus y equals 2. Okay, when you have that and you graph that, there are 3 different results that you can get, and they have these goofy names that mathematical people call them, and I don't even know why, but I just want you to have them in your notes so you can look up something there. If the lines cross, like if you were to graph this thing, and I don't know if it does or not, if the lines cross at one place like this, it is called, and you can read it for yourself in the book there, consistent and independent. Consistent and independent. Okay, consistent and independent means you're going to get one solution. One solution. Your other option, or one of your other options, is the lines that you graph are the same exact line. Oh, great. I don't know, how would you show this in your exact line? You could do 2 different colors. Okay, on top of each other. If it's the same line, it's called consistent and dependent. In this case, you have an infinite amount of solutions because anything on that line is a solution. And your third option is that the lines, when you graph them, are parallel. And when they're parallel, it's called inconsistent. Inconsistent. And we talked about this before. There is no solution when they're inconsistent, which makes sense. No solution. So just make sure you have that in your notes. It's not really anything that's I suppose, how would you know right off the bat if something is inconsistent without having to graph it? What do you know about parallel lines? We talked about this. Yeah, they would have to have the same slope, but not only the same slope, they'd also have to have the different y-intercepts. Okay, because these, if you were in this case here, would also have the same slope, except this would have the same y-intercept. So this one is same slope, same y-intercept. This one here would have different slope. That's all there is to it. If you have 2 lines that have different slope, they will cross eventually. You know, it might be miles and miles down the road, but if something has different slopes, somewhere along the line, they are going to cross. It might not be on your piece of paper, it might not be on computer Morris, it might not be on, but somewhere they will. So now you know when they ask you about consistent, independent, whatever stuff, or ask you to label those things, you will know based on your notes right there. And that, children, is gonna be